Hi, and welcome to this flipped instructional session. This is Earth Science Semester A, and today we're going to be talking about topics from Lesson 4.05 to 4.10, focusing on plate tectonics. I am Mrs. Fessel. As I said, we're going to be talking today about plate tectonics. Our goals for today are to review plate tectonics, summarize seafloor spreading, and summarize what causes plate tectonics. As a review from earlier lessons, the theory of plate tectonics is that the Earth's crust is broken into pieces called plates. All the plates of the Earth are shown in this picture here, and these plates move slowly across the Earth's surface, very slowly. We're talking centimeters a year. So how does this happen? That's what we're going to focus on today. So what are the tectonic plates? The tectonic plates are actually pieces of the lithosphere. The lithosphere is the solid, rigid top outer layer of the Earth. That's the one we live on. The lithosphere includes the crust and the uppermost part of the mantle. Geologists group these two layers together because they behave similarly. The lithosphere is solid and rigid, but, like anything, when under stress, it might break. These tectonic plates float on a weaker layer of the mantle known as the asthenosphere, which is actually plastic-like, incapable of changing shape or flowing as a solid without breaking. So again, we have the lithosphere, the top layer, that's the one that's broken into plates, and right underneath it we have the asthenosphere, which is a plastic-like layer. So here in this picture you can see what we just talked about, the lithosphere, the outermost layer, and the asthenosphere right below it. So the Mid-Atlantic Ridge is a continuous chain of volcanoes on the ocean floor where lava erupts and the brand new crust, brand new lithosphere is created. Nearly every day, somewhere on this mid-ocean ridge, there is likely to be an eruption of lava or an intrusion of magma that builds the ocean crust. So as you can see in this picture here, this mid-ocean ridge, which runs down the middle of the Atlantic Ocean, the plates are moving apart in separate directions. The asthenosphere, that hot plasticky layer that we just talked about, comes up, hits the cold ocean water, fills the crack, and cools. So the Mid-Atlantic Ridge that we've been talking about runs, as the name would suggest, right down the middle of the Atlantic Ocean. So this is where brand new crust is being formed. As you can see in the map up here, the red indicates the youngest oceanic lithosphere, 10 million years old. So you can see that right along the crack here, the crack of these two plates, and the crack of many plates, is where new crust is being formed. Old crust is being destroyed at the edges of the plates here, which is what we're going to talk about here in a minute. So that crack that we just talked about through the middle of the Atlantic Ocean is what causes and where seafloor spreading takes place. It occurs along all mid-ocean ridges. Molten material from below the Earth's surface moves upward, cools, and forms new oceanic crust. So right here at the mid-ocean ridge, that's what we were talking about. The plates move apart and new crust is created right here at this ridge. Older crust will then move farther away from the rift in either direction, and new crust forms in its place. All right. So now we've talked about the plates moving, and why do these plates move? There are two big reasons, gravity and convection. And within gravity, we're going to talk about slab pull and ridge push as being part of gravity. So first we're going to talk about convection. Convection, this picture is down here because it's similar to a pot of water boiling. We have the heat down here, that represents the core of the Earth over here. Then we have the cool air up here, which is the same as the cool air and water that surround the Earth. So the center of the Earth is hot, just like this flame. That causes the asthenosphere, which we just talked about being the upper part of Earth's mantle, that is plastic-like and capable of changing shape, to heat up. When things heat up, just like water, they rise. Just like air, the asthenosphere of the Earth rises. That is because they become less dense. The molecules move further apart, are lighter or less dense, and rise. Exactly what's happening in a tea kettle. If you've ever noticed when water boils, the bubbles go in circles. That's because of convection. And then the opposite part is when the molecules reach the top of the Earth, they cool down because where we live up here on the surface of the Earth, it's cooler. When the magma reaches the surface, it begins to cool. That's because it becomes more dense. The molecules move closer together and it sinks. Then the cycle starts all over again right here. So right here, the molecules become warmer, heat up and rise, become cooler, more dense, and sink. This cycle can take millions of years, so it's not happening very quickly. So the second thing that causes these plates to move is gravity. Gravity causes two things, ridge push and slab pull, which we're going to talk about. The mid-ocean ridges that we talked about a minute ago are higher than the surrounding area. Gravity wants to push things towards the middle of the Earth. That's why we're stuck on the Earth, because gravity is trying to push us towards the middle. So gravity pulls down on this mid-ocean ridge right here, and that pushes the slab down away from the mid-ocean ridge. As we talked about a minute ago, the gap right here gets filled with magma, which cools and becomes brand new oceanic crusts. Then the opposite, well, not the opposite, but something similar is happening down here. Gravity causes slab pull. Again, gravity wants everything to move towards the center of the Earth. So gravity pulls this end of the plate down into the Earth because its cool, dense crust sinks into the mantle, pulling the rest of the plate along. Both ridge push and slab pull depend on gravity to act on the edges of the plate. So that's the end. Please attend the flipped follow-up on your class schedule, and I look forward to seeing you soon. Bye.